0 to the 0 equals 1. Google says 0 to the 0 equals 1. Bing says 0 to the 0 equals 1. Have you heard of this guy Euler? He discovered this. He said 0 to the 0 equals 1. Are you really going to doubt the guy that figured this out? In fact, you see this variable e? It's used in continuous growth formulas and all kinds of different stuff. Do you know why it's called e? Because of the e in his name. It's named after him. Even if you don't agree with 0 to 0 equals 1, aren't you curious why tons of other competent people say that 0 to 0 is 1? Here's why. It's called the empty product. It's what happens when you multiply by no factors. What this 3 means is that we are multiplying by 3 2's. That changes the number, because when we multiply 4 by 3 2's, it now becomes 32. It's the fact that there are a certain number of 2's here, that's what changes it. Now, if there were no 2's here, we call it the empty product because there's nothing here. It's not being multiplied by anything. The answer is still going to be 4. This space right here is a 1, and that means 2 to the 0 equals 1, and this concept is called the empty product. The same logic holds when it's 0 to the 0. It doesn't matter if it's a 0 or a 2, there's an empty product. There are no zeros there. Therefore, our 4 is not going to change because it's not being multiplied by anything. It's an empty product. Well, the only way this is true is if that's a 1 inside there. This is the reason why so many people say 0 to the 0 equals 1. Some people said 0 to the 0 is undefined. This is their argument. They introduce a variable x, and they set it to the power of 0. This must be equal to x to the power of 1 minus 1. And that's the same thing as x to the 1 over x to the 1. And that's the same thing as x over x. Now, the problem with this is division by 0 is not possible, so we have to put a restriction on this statement. We have to say x cannot equal 0. Now, when people see this, they go, oh, well, therefore 0 to the 0 is undefined. But that is not true. It'd be more accurate to say x to the 0 is undefined for x equals 0. Well, undefined means no definition. So in other words, algebra provides no definition for 0 to the 0. So if algebra has no definition for 0 to the 0, I'm going to defer back to the empty product, which tells me 0 to the 0 equals 1. Something else people say is that 0 to the 0 is indeterminate. In this context, it means if you're taking the limit as x approaches a of a function f of x to the power of another function g of x, and each of those functions evaluated at a are equal to 0, and then we do direct substitution and plug a into both of these x's, we get f of a to the power of g of a, and now we get this thing that looks like 0 over 0. But this is all built off of algebra. And if you remember, algebra has no definition for 0 to the 0. So we cannot solve this limit with direct substitution. We have to use other methods. And here's a more accurate statement for this one. The limit as x approaches a of f of x to the power of g of x gives an indeterminate form if f of a equals 0 and g of a equals 0. Look at all these qualifiers. This is not the same thing as this. This one deals with limits and functions and algebra and all this other stuff. This one is talking about 0 to the 0, which means we have no zeros and it's an empty product. I do not believe it is a logical leap to go from here to here. And I'm going to defer back to the empty product, which tells me that 0, 0 equals 1.